Welcome back. This is my second video in the series on how to do time series and forecasting models in R. This video is going to cover how you use certain commands and functions, data structures in R to represent and analyze time series objects. The first thing I want to just mention to you is that there's at least two generations of time series commands. So time series was built into the original S. S preceded R way back in the early 80s, maybe even the 70s. And so many of these time series objects have been around since then, but then they've all been kind of updated, especially since the introduction of ggplot, which I like to call it the third generation of graphics in R. And so the forecast library and others use the ggplot functionality. So often there's more than one way to do things, and sometimes the old functions are easier, sometimes the new functions are better. So I'm going to try to stick with the newer ones, but sometimes I'll be using the old ones. So the very first thing you want to do, especially if you're going to use the newer functions, is load ggplot2 library, the forecast library. Remember, I'm using the Heinemann book. Heinemann has all the data sets in his book stored in some libraries, FMA and FPP2. So I would just automatically load those at the beginning of your R session. So as an example, here is my R Markdown. Actually, this is just an R program. First thing I do is I load those four libraries. Okay. Next thing you need to know is that there is a class called TS. Okay, so TS is a time series object. And you assign a time series object just by giving a vector of data. And then here are the most important options that you can add to this. So you can give it a start date. So for example, if I say start is equal to 2020, 3, what that means is this is the first month is going to be the year 2020, and it's going to be March. Or if this is quarterly data, it'd be the third quarter of the year 2020. Usually you would specify start. You wouldn't specify end, but end gives you the end of the series. The next argument that you really need to know about is frequency. So frequency is going to be used to signal seasonality. So remember that seasonality means there's a regular pattern that occurs within the data. And so you specify the length of that period, that regular period. So for example, if we have quarterly data, as we had with the Amazon example in the previous video, quarterly data means specify a frequency of 4. There's a different argument that you could specify, which is delta t. And if you say delta t equals a fourth, that's the same as frequency equals 4. If you want monthly data, you'd say frequency equals 12. If you want weekly data, you could say frequency equals 7, or delta t equals 1/7. All right, so that's how I create a time series object. Now, what follows are a lot of other functions that we use to, kind of manipulate and interrogate a time series object. So one of those is called the window command, and this is like a subset command. So I just want to extract, maybe I have data from 1970 all the way through to the present, and if I just want to extract say a 10-year period between 2010 and 2020, I'd use the window command. So start returns the start date of the TS object, end is the end date, frequency gives you the frequency associated with that time series object. Time is going to extract just the time index for the time series object. Cycle is going to extract just the period numbers associated with each row. I'm going to illustrate these in the next slide, so just bear with me. Often we're going to want to look at what happened in the previous period or the next period. So that's called lagging, or what happens in the next period is leads, the lead period, the lead value. And so we can use this lag function to extract either the next or the previous value accordingly. Beware, if you're using dplyr, which you're almost certainly doing if you're doing ggplot, there's a different lag function in dplyr that works a little bit differently. And so you want to use stats : lag or dplyr : lag, depending on which one you want. The dplyr one, as an example, works with the group by command. So you can lag things by some group by variable. Can't do that with the base R version. So just make sure you know which one you want. We're going to be doing a lot of differencing. So differencing means take the difference between successive observations, and the diff command does that. Sometimes we'll want to aggregate data, and there's a function called aggregate that does that. So let me give you an example of how this works. So let's go back to the Amazon data. To keep this example manageable, I'm just going to give us 3 years of data. And so if I want to create an object called Amazon, that's a time series object, I could give it just a vector. So here is a vector with those 3 years or 12 values. Now, I would specify the start date of this time series. So the very first year is 2003. R is going to assume that the first observation is the first quarter in that year. So I don't need to do what I did back here, where I said explicitly, this is 2020 third period. This is just going to assume that it's the first period. And then because I've got quarterly data, I'm going to say that the frequency is 4. All right, so if I print, so just display Amazon, what you will see is here is every year, and then the seasons get shown as columns. And so you'll see that I've read this in. I can use summary. Summary just computes the 5-number summary plus the mean, as it does with any numeric variable. If I say, what is the starting date? Well, you'll see that it's actually 2003 first quarter, just as I had intended. What is the end? Well, 2005 quarter 4. What frequency is associated with this data set? Well, the frequency is 4. So there's quarterly data. I'll just mention, sometimes you get more complicated frequencies. So for example, if you have weblog data may have the number of visitors every hour on every day. And so you could get very complicated seasonality where you have day effects. So I probably have fewer web visitors in the middle of the night than I do during the day. I probably have day of week effects. So maybe I have more visitors coming during the week than on the weekend. I could also have some annual effects where maybe in summer I have more than in winter. So that's an example of compound seasonality. We're not going to really talk about this in this class, but there is a section in the Heinemann book that talks about some additional libraries that you can download to handle that sort of more complicated seasonality. All right, so those are some of the basic time series functions. Let's go look at the diff and the lag functions. So I've put together a little example where I'm going to extract the time variable. And remember I said that's the time index. Then let's get the cycle number, just see what that cycle function does. Let's go get the original data. So this would be the y sub t using my notation. Let's compute differences, and then I'm going to explicitly use the stats package so that I don't get the dplyr version. and compute some lags. Okay, so first off, what you'll see is that the time component is expressed as, for example, 2003.00. Then the first quarter would be 2003.25 and so forth. And so what we have is an index giving the value of t, if you will. Cycle is just going to be the quarter number. So the first one is quarter 1 through quarter 4, quarter 1 through quarter 4, and so forth. So that's exactly what cycle does. I put the value of this right next to it. And then let's see what happens with differencing. So differencing means I'm going to subtract the current value from the previous value. So if I take 1.1 minus 1.084, the difference is 0.016. Likewise, if I subtract 1.134 from 1.1, I get 0.034, which would be that difference. Notice I can't subtract the previous value from this one, from the first value in the data set, because the previous value is missing, and therefore the difference is indicated as being NA. All right, so that's what differencing does. What does lag do? Well, lag just says, give me the previous value of this variable. So you're going to see for 2002 quarter 4, lag applied to this value gives the exact same value. And then you can just map 1.1, 1.1, 1.134, 1.34. So that's what the lag function does. Okay, finally, I want to illustrate the aggregate and the window commands. So one way to handle compound seasonality is to aggregate over some other period. So for example, if I want to get rid of my the Amazon data, recall, had these peaks every fourth quarter. I could just aggregate this to the year level. So this is saying aggregate the Amazon data to a frequency of 1 and do it with the mean. Sometimes you want to do the sum, which would add up the values instead of averaging them. And so what's happening here is if we average the 4 values from 2003, we get this value. So another example of this is maybe I don't care about COVID cases today, because today is going to get affected by when the labs are open, when stuff gets reported and recorded. So it would make perfect sense to look at COVID cases weekly. And so often in the newspaper, you're going to see 7-day figures, and that takes out the seasonality part of it. So that would be another example of why you might want to aggregate something. Finally, the window command extracts just a window subset of the time series. So if I only wanted data from the third and fourth quarters of 2003 through the first and second quarters of 2005, this would be one way to express that. I could also express this as a C, C 2003, 3 and 2005, 2. But then that returns just the slice of the Amazon data. If you're interested in the entire time series that I used back a couple slides ago, so this is way back here, I've given you the entire Amazon data as well as the entire Treasury bill data here. So if you want to play with that, go for it. Okay, the last thing that I want to mention about these functions in R is different plots that you can generate. So one of the most useful commands is just autoplot. So if you autoplot a time series object, you get the time series plots that I was showing a couple slides ago. And so whenever you have time series of the data, the absolute first thing you should do is look at one of these time series plots, plotting the y value against t, against time. And so we clearly see the seasonality there. There's a few other plots that are useful that you probably want to look at just to get some understanding. I would, remember one of our tasks is to describe the data. Well, these plots are extremely useful. Another one of these is called the subseries plot. So subseries plot is the old name, GG subseries plot is the new name. And so here's an example of a subseries plot. And so this plots the data by quarter. These lines indicate the averages across all of our quarters, and these vertical lines indicate the ranges. And so what we can clearly see here is that Amazon sales tend to be quite low in quarters 1 through 3, and then they spike in quarter 4. These are the values over time for Amazon. So what's happening in quarter 1 is that their sales are increasing over time, and you can clearly see the trend versus the seasonal part. Now, another plot is the season plot, or if you want the GG version, GG season plot, just prepend GG to whatever. This is just another way to see the seasonality. So we see a different year with different lines indicated by color here. And so what you can see is that clearly in every year, quarters 1 through 3 have lower sales than in period 4, and the trend is increasing. So sales are going up over time.